In this video, we want to look at testing dependent samples. Now, in the last video, in sections 8.1 and 8.2, we talked about the difference between independent and dependent samples, and we looked at specifically in the last two examples or sections, independent samples. So let's refresh our memory on the difference between independent and dependent samples. Now, an independent sample are two samples that come from two unrelated kind of populations. There's nothing to connect or pair the one sample to the other. Dependent samples come with each value of one sample can be paired or matched to a corresponding value in the other sample. So sometimes these are called matched paired or paired samples. I use this term matched paired a lot to kind of explain these dependent problems. So just to kind of refresh our memory on the difference. So are these examples independent or dependent? One group of subjects is treated with the drug while a separate group of subjects is given the placebo. This is going to be independent. The one group is unrelated to the other group. The second one, blood pressure levels are measured before and after a drug is taken. This is going to be dependent because each person is getting measured before and after the same thing measured twice. A group of subjects has the length of their left foot and the length of their right foot measured. These are dependent because every measurement of a left foot can be paired to a measurement of a right foot. Now, there's a lot of situations where it's very important to compare these two sets of data, the before and after and those types of things. And that's what we want to look at. So as we look at this matched paired or dependent samples, let's look at some notation so that we're all kind of on the same page. First off, mu sub d is going to represent the differences of our two samples. This is all going to be about the difference between our two populations. So d bar is going to be the mean of the differences from the sample. Once again, it's related to the difference. S sub d is the standard deviation of the differences of the sample. And n is the number of paired data. So let's look at an example and kind of talk about these different variables and how they work. A sample of 10 student scores on the SAT before and after a prep course are given in the table. So we have the before the prep course, what these 10 people's score was, and then after the prep course, what these 10 people's scores were. And so what we're testing is there sufficient data to conclude that the prep course is effective at raising the scores? Now, the first thing you want to do is you have to decide how you want to subtract, how you want to find the difference. And in this case, I am going to take after minus before. And I'll explain as we keep going here. If you did it the other way, it would still work. So if I take after minus before, I get 20, 0, negative 10, 40, 30, 10, negative 30, 20, 20, and 10. So the next thing we have to do is we got to talk about, well, how do we write our H sub O and our H sub A? How do we write those in this situation? So let's go back. And here is going to be our null and our alternate hypothesis. We're always going to look at this mu sub d, which remember is the difference of our population means. And we're always going to say there is no difference. They're the same. There's nothing different between them. And so we're always going to have our H sub O as mu D equals 0. Always. Then our alternate hypothesis would there be mu D is less than 0, mu D is greater than 0, or mu D is not equal to 0. And that depends on the problem. But it's always going to be 0. Because you're always looking at the difference, and these are all 0. So what you have to decide is, based on the way you subtracted, is it going to be greater than 0, or is it going to be less than 0? And that is going to depend on how you subtract. And you can do it either way. So if we look at this example, we're looking at the prep course, and we want to see, is it effective at raising the scores? So if I take after minus before, we're trying to see, did the scores go up? So this should be greater than 0. My difference should be greater than 0. If you would have subtracted before minus after, and then you would have had negative 20, 0, 10, negative 40, negative 30, negative 10, 30, negative 20, negative 20, negative 10, and you did before minus after, you would have done less than 0. So it all depends on the problem and which way you subtract. If you think about it like you're going on a diet and you have after minus before, and you're on a diet, would that be greater than 0 or less than 0? If you're testing if the diet works. Well, if you're on a diet, after should be less. So when you subtract after minus before, in that case, it would be less than 0. Because a diet, you should be, the after should go down. In this case, this is a prep course. The after should go up, so we have greater than 0. Okay, so there's lots of different ways you could do it. Now, to make this as simple as possible, once we have done that, once we have subtracted, once we have got our H sub O and our H sub A, really all of this original data of the before and the after doesn't matter. All we're going to do now is we have a new set of data, and we're going to do a one sample t-test with this new set of data. We already have these written down, and we've gotten these figured out based on which way we subtract. But once we subtract and find the difference, we now just have a new set of data. So all we're going to do is take that new set of data, and I've put in that new data, 20, 0, negative 10, into the calculator. And then I can go to my one variable stats, and I can get my D bar is 11, and my S sub D is 20.25, which I got from the calculator. But reality, this is the exact same kind of test you did before when you did a one variable t-test. So if you thought of this at this point as X bar and S, it really wouldn't change much for what you're doing. The next thing we need to do is we need to find what's the p-value for this new set of data in a one sample t-test. So when you do these problems, you are going to use, for a matched paired dependent samples, you are going to use a one sample t-test. You could do stats or you could use data. It doesn't matter. There is our 0, and we are saying that we are greater than 0. There is our mean. There's our standard deviation. Always 0 for our mu sub 0 here, remember, for these matched pairs. And we get our p-value to be 0.0599, which is greater than our alpha. So we fail to reject. So now let's think about what does that mean. If we fail to reject, there is not enough evidence to support that our difference is greater than 0. There's not enough evidence to support that after is bigger than before. On all of these, if we fail to reject, we are saying there is no difference. So now we write our sentence, and so our sentence is going to be, there is not enough evidence to support that the prep class improves scores. P-value was close. It was basically 6%, which is bigger than 5 though. So we fail to reject. So we either say there is not enough evidence to support that the prep course effectively raises the scores. So really when you do these problems, what you're going to do is you want to start off by subtracting. And you can do it either way. Once you subtract, you want to write your h sub o and your h sub a and decide, should my h sub a be greater than 0, less than 0, or not equal to 0? And then once you do that, forget about all the data. Just look at this new single one sample t-test. Let's try another one. Are America's top cheap executive offers really worth all the money? One way to answer this question is to look at this chart where it compares how the CEO's pay increase compares to the CEO's increase. Okay. So what I'm going to do here is I'm going to take A minus B. I am going to subtract. So I get -3, 2, -5, -4, -10, 15, -6, -7. And I have to think, okay, which way did I subtract? My h sub o and my h sub a. My h sub a is mu d. This is always, the difference is 0. And the question is, does the data indicate that the population, the percent increase of corporations is different from the CEO? So that would be not equal to. So once I have those two things, I can really forget about all of this data and just look at this now new t-test, one sample t-test. And if I did that, my average of that is -2.25. You found that on your calculator on the computer. My standard deviation is 7.779. I typed these into the calculator already. And then if I did my one sample t-test, my p-value is 0.44, which is greater than alpha, so I fail to reject. So since I fail to reject, we're saying there's not enough evidence to support that there is a difference. They appear to be about the same. So for this homework in section 8.3, these are dependent examples. And in terms of the hypothesis testing, you're basically going to be doing a one sample t-test after you subtract. So you subtract, you determine your h sub o, You determine your H sub A. Is it greater than or less than or not equal to 0? Then you just take your differences and you do a one sample t-test with your differences.